We'll proceed in summation series to integral. Summation series to integral calculus. This is the discussion that we are pursuing. We are in a war kind of phase where can we calculate summation series through integral calculus. Generally, people prefer some kind of very complex algebraic way to calculate the summation series. Okay, and we are proceeding in summation series for the 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 plus 5 by 6 plus n by 1 plus n. This is what the discussion that we are pursuing now. Okay, as far as this discussion is concerned, then there are two ways we can find the solution. 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5. One is repeated addition, and that we have already talked about. Divide problem into n different parts. Now first part is 1 by 2, second part is 2 by 3, third part is 3 by 4. Kind of make all the parts look exactly same. Yeah, it is possible. It is possible if each part is x by 1 plus x. If each part is x by 1 plus x, of x by 1 plus x, then all parts are same, where x is variable. But writing all the parts separately, if I write on paper all the parts separately, 1 by 2, 2 by 3, 3 by 4, instead of that, I can rewrite as x by 1 plus x, 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 like that. If I have 5 plus 5 plus 5, it can be rewritten as 5 into x, 5 where x is 3, 5 into 3, 5 into x where x is 3, or 5 into dx, 5 into dx. If it is 5 into dx, the limit will go 0 to 3 if I have to add 5 3 times. Similarly, if I want to add 1 by 1, x by 1 plus x, x by 1 plus x, x by 1 plus x. Okay, n number of times we need to add. I believe it is alright. X by 1 plus x, x by 1 plus x, x by 1 plus x. If I keep on adding, then n number of times I have to add x by 1 plus x. So I can say 1 by 1 plus x into x, where x is n. Now it is same as function over x into x is same as function over x dx, where x will go 0 to n, means it will come as x by 1 plus x dx, x 0 to n. Numerator x is 1 plus x, numerator is x, that is 1 plus x minus 1 plus x minus 1. Oh, x plus 1, x can be written as x plus 1 minus 1. Therefore, will come as 1 minus 1 by 1 plus x. Okay, now we can integrate. 1 minus 1 by 1 plus x would become x minus log of 1 plus x, x minus natural log of 1 plus x. Okay, 0 to n, n minus natural log of 1 plus n. 0, zeros all will become 0, 1. Means the result is coming as n minus natural log of 1 plus n plus some constant. Okay, someone can check the result. It is exactly the same result that is published in the books. N minus natural log of n plus 1. That is also called harmonics of n plus 1. Harmonics of n, capital H and as a subscript n. Capital H, bottom right subscript as n, Hn. Okay, Hn. Harmonics of n is nothing but natural log of n plus some constant. Typically, that constant is around 5.57. So, if I have something like that, n minus natural log of n plus 1 plus some constant, I can rewrite as plus some constant or minus constant, whatever it is. Okay, constant can be negative also. So we can rewrite it as n minus harmonics of n plus 1. Harmonics of n plus 1. Why it is harmonics of n plus 1? Why it is harmonics of n plus 1? Because the constant what we are seeing, it will typically come as lambda only, whatever there. Anyway, someone can write on the paper and he can think about it. This is what the solution that is available in the book. This is not the perfect solution. If I take v vector, if I take lambda, okay, let's take n equal to 1, n equal to 1, then how much it will be? N is 1 minus natural log of 1 plus 1, that is 2. Natural log of 2 is 0.7. 1 minus 0.7 is 0.3. 0.3. Okay, if it is 0.3, then it will be 0.3 plus constant. So constant will be 0.2. Okay, if I take a higher value, actually, please watch our previous video. If I take a higher value, then slowly lambda comes in a lambda comes to around 0.47, 0.45, 0.47. Okay, but the problem is if I set lambda as 0.2 the way it is, then it will not be perfect if I take n equal to 4. If I take n equal to 4, let's take n equal to 3. Then it is 3 minus natural log of 4. Natural log of 4, I remember actually. It is 1.4. So it is 3 minus 1.4. That will come as 2.6. 2.6 plus zero point 0.2, we had calculated the constant value, 2.8. It will come as 2.8. Now let's measure actually 1 by 2 plus 2 by 3 plus 3 by 4. This is n equal to 3. Okay, 1 by 2 is half, 2 by 3 is 0.67. That will come as 1.17. 1.17 plus 0.75. It will come less than 2. It will come less than 2. But if we proceed with the what result we are getting, n minus natural log of 1 plus n, up, I think we make mistake. We'll try again. What is n equal to 3 if I do, then I have 1 by 2 plus 2 by 3 plus 3 by 4. 1 by 2 plus 2 by 3 come as 1.17 plus 0.75. 0.75 plus 1.17 will come as 1.92, I think so, around that. 75 plus 17 will come as 92 only, 1.92 around. Let's go through the formula. Formula is n minus natural log of 1 plus n plus 0.2. This is what we have calculated earlier. Now n is 3 minus log of 4, 1.4. 3 minus 1.4 is 1.6. 1.6. 1.59 rather. 1.41 that is. 1.59 plus zero point 0.2 is less than 1.8. The wanted result is 1.92 and here it is 1.8 less. Means lambda will increase by 1.11. No, 0.13. Now it will become, earlier it was zero point 0.2, now it is becomes 0.33. 0.33. So lambda value will grow and it will reach up to around 0.45. 45 if I go more in n. So net solution will be n minus natural log of 1 plus n plus lambda, and that is 0.45. But that will not work in the lower n value. If I take n equal to 1, then that result is completely wrong. N equal to 1, this side it is 1 by 2, that is 0.5, and this side 1 minus natural log of 2, that will come as 0.3 plus zero point 0.3 will come as 0.3. 0.3, yeah, 1 n minus, yeah, it will come as 0.3. 0.3 plus 0.45, that we, if I settle down in that, that will come as 0.75. 0.75 is much bigger than zero point 0.5. It cannot be tolerated. This is very high value. Means if I fix a lambda value, harmonics of anything, if people who see the book, the result is n minus harmonics of n plus 1. That is natural log of n plus 1 plus some constant. Okay, miss, this will not work. This is what the solution people provided. It is not perfect. Okay, we will go through another methodology called, this is called repeated addition that we saw. Repeated addition is a good addition, good work, but provided people sacrifice the actual result. If people are ready, if someone is ready to sacrifice for the actual result, then I believe there is no problem in repeated addition. We are trying to solve some series through two ways in integral calculus. Through two ways in integral calculus. First way is repeated addition and second way is successive approximation. Both way are not available in any of the book. Okay, successive approximation, we start with something and keep changing the value so that it will match some target value. And when it reaches there, then we do the final integration. The concept of successive integration, many times we have talked it. In successive integration, again, there are two ways. Two ways. First is for successive integration, try to find the summation series through a function. Okay, what is the function? 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5, so on. It is same as sigma. Sigma x equal to 1 to n fx, function over x. If I add function over x, function over x, function over x, function over x n times, then I'll get this summation. What is function over x? That is x by 1 plus x. This starts with x equal to 1 and it goes till x equal to n. What are you saying? That is 1 by 1 plus 1 plus plus 2 by 2 plus 1 plus 3 by 3 plus 1 plus n by n plus 1. So I can rewrite it as, now if I rewrite it as sigma x equal to 1 to n fx. If I try to draw it through diagram now, if I try to draw it through diagram, then it is x-axis. This is x-axis and this is function over x. Hope will go like this. This is function over x. Function over x is a discrete function. It is not a continuous function. Discrete function means function over x. This is function over x. So that will go like this. At the end, it will reach 1. It will start with half and maturity will be 1. Yeah, like this. Maturity will go to 1. Where when x equal to 1, then height is 1 by 2. When x equal to 2, then height is 2 by 3. When x equal to 4, then height is 4 by 5. When x equal to 10, height is 10 by 11. When x equal to 20, height is 20 by 21. More or less, it is hitting 1 starting from the half. Okay, and then it will become like 1 only. It will go. Okay, this is, now if I say I have a function over x and function over x is x by 1 plus x, then this is sampled at x equal to 1, 2, 3, 4, 5, 6, like so. Okay, if it is sampled at many locations, it will be considered as, or in another way, someone can think of fx as considered. Someone will ask, what is your fx? This is x-axis. This is function over x-axis. This is y-axis and this is x-axis. When x equal to 1, then I have a vertical that is 1 by 2. When x equal to 2, I have a vertical 2 by 3. When x equal to 3, I have a vertical 3 by 4. When x equal to 4, I have a vertical of 4 by 5. When x equal to 5, I have a vertical of 5 by 6. Like so. Okay. This means that I have set of vertical. If I connect top of all the vertical, if I connect top of all the vertical, then it will draw a curve, and this is the curve. Okay, this curve is generated by connecting all the vertical, which is sampled at x equal to 1, 2, 3, 4, like that. And if I draw a line, that line equation in fx equal to x by 1 plus x, which does not have any value, that is undefined. When x is in fraction, it has to be a non-fraction value. In computer science, it is like it has to be integer. Float, where it will not work. Okay, decimal, it will not work. Fraction will not work. It has to be a whole number. Okay, now in that fashion fx is there. So if I say, what are you trying to do? I am trying to, this is the main part. After that, it is not that difficult. Or if it is difficult, then it will be difficult in integration only, not in concept that we are proceeding upon, that we are suggesting. Okay, now when x equal to 1, then height is 1 by 2. Like that, I have to add n number of verticals. I have to add n number of verticals. Now, if there are n number of vertical, consider this is vertical at x equal to 1. There is another vertical at x equal to 2. Means there is a gap between x equal to 1 and x equal to 2. There is a gap between x equal to 2 and x equal to 3. Okay, let's take another function called gx. This is fx. Consider there is another function called gx, and gx is a continuous function which can be sampled at any x. Now let's take between x equal to 1 to 2. I have a region, and this region, if I go and it will hit the gx like this. This is a sub area underneath the gx between x equal to 1 and 2. There is a sub area under gx between x equal to 2 and 3. That is like this. There can be n number of sub area under gx that spans from x equal to 1 to last sub area will be between x equal to x equal to n plus 1. If there are three vertical, one vertical, two vertical, three vertical, then x is 1, 2 and 3. So I have to add three vertical in fx. But if I talk in gx, then there has to be equally three sub area. Then first area is between x equal to 1 to 2, second area is between 2 to 3, and third area is between 3 and 4, where 4 is not there, but still we have to consider that. What are you trying to say? I am trying to say that when x equal to 1, we have fx as height as 1 by 1 plus 1, 1 by 2. If I talk in sub area, then between x equal to 1 and 2, I have a sub. This sub area should be exactly same as the vertical at x equal to 1. Then next sub area between 2 and 3 should the sub area, that this is gx. This gx sub area should be exactly same as the vertical at x equal to 2. Next sub area between 3 and 4. This sub area should be exactly same as vertical at x equal to 3. If that is the case, then summation of vertical at x equal to 1, 2 and 3 will become exactly same as summation of 3 sub area, or full sub area under the gx between x equal to 1 to n plus 1. Makes sense? Means I am trying to say sigma sign summation x equal to 1 to n fx function over x, sigma x equal to 1 to n function over x should be equal to integration 1 to n plus 1. Here summation is x equal to 1 to n. Then there will be n vertical. Here integration sign is 1 to n plus 1, so that there will be n sub area gx dx. If this is the scenario and we know gx, then we can calculate this summation through gx only, because calculating the repeated summation we do not know the answer. Concept is, can we find a continuous function gx that is in parallel to discrete function fx, so that repeated summation of x equal to 1 to n fx dx will be same as summation limit 1 to n plus 1 gx dx. What is gx? That I don't know. That we have to find. Is there any another philosophy behind it? Yeah, there is another philosophy behind it. The main concept is I have to add n number of vertical, where at any x, the vertical height is x by 1 plus x by x plus 1. That will correspond to a function called fx, that is a discrete function. There is a gx that we have to find. Okay, now gx we have constructed in a manner that there are n subsections. Each subsection corresponds to one vertical of fx. Then I can go left side also. If I go left side, then I have x equal to 1. Then area between x equal to 1 and x equal to 0. This is one sub area. Then between x equal to 2 and x equal to 1, another sub area. If I go like this, then nth sub area will be between x equal to n and x equal to n minus 1. Okay, nth sub area. If I add all the sub area, then again it will be under gx only, and both should be exactly same. What do you mean? I am saying limit x equal to 1 to n plus 1 gx dx should be exactly same as underneath area should be exactly same as limit x equal to 0 means 1 minus 1 0 to n g2x dx. I have to find another gx in this manner where but end result integrating from 1 to n plus 1 dx dx should be exactly integrating 0 to n g2x dx. I have to find gx, I have to find g2x. G2x will be different, but at the end integral placing the limit should be exactly same. So we'll try with the first one, that is going right side. If I go right side, then let's take this is fx. If I go right side, if this is fx, now take any x here. If I take any x, then fx is 1 by x, sorry, x by x plus 1. If it is x by x plus 1, then what about gx, that sub area? Then sub area will go from x to x plus 1. That corresponds to a vertical at x equal to x. This sub area will correspond to a vertical in fx at x equal to x. Now means fx equal to integration x to x plus 1 gx dx. This is the one sub area from x to x plus 1, and that should be exactly same as the vertical at x equal to x. If that is the same, then every portion we can generalize over it. Let's begin now. If fx equal to gx dx, then gx equal to dfx by dx. Okay, fx is 1 minus 1 by 1 plus x. X by 1 plus x can be rewritten as 1 minus 1 by 1 plus x. Natural, if I do the differentiation, it will become plus 1 up, it will become 1 differentiation is 0 minus 1 by 1 plus x. Differentiation of this will turn into 1 by 1 plus x whole square. 1 plus 1 by 1 plus x whole square. If I place as gx 1 by 1 plus x whole square dx, then integration for this will become minus 1 by 1 plus x only. So minus 1 by 1 plus x integration result is this. Limit is x to x plus 1. Someone has to set it. Okay, if someone sets it, then it will become minus 1 by x plus 2 plus 1 by 1 plus x. Makes sense? So it will become 1 by x plus 1 minus 1 by x plus 2. It would become, settling it down, it will become 1 by x plus 1 into x plus 2. Makes sense? Okay, actual is x by 1 plus x. The wanted result is x by 1 plus x. The result what we are getting is 1 by x plus 1 into x plus 2. If I divide this 1 by x plus 1 by 1 by x plus 1 x plus 2, it will become x into x plus 1 into x plus 2 by x plus 1. Both will go out, and then it will become x into x plus 2. Means I have to multiply by this to have the result. Make sense? Okay, then we'll try again. We had started with 1 by x plus 1 whole square. Now I have to multiply with x into x plus 2. X into x plus 2. If I see it closely, x into x plus 2 by x plus 1 whole square, this degree will come as 1 only. Make sense? X into x plus 2 by x plus 1. If someone is crazy, he can start now again. Okay, again means now instead of trying with 1 by 1 plus x whole square, at gx, we have to try with x into x plus 2. That is x square plus 2x by x plus x plus 1 whole square. If someone can compute this integration, all the best. Otherwise, we will think something. But if someone is watching closely, then x into x plus 2 by x plus 1 whole square, it has degree of 1 only, because numerator has degree of 2 and denominator has degree of 2. 2 by 2, it is 1 only. Anyway, if I see the previous one, that it has degree of 1, it has numerator has degree of 1 and denominator 0, and denominator has degree of 2, whereas the actual is x by 1 plus x. The numerator is degree of 1, denominator with both degree are same. Again here both degree are same, means we can start with as it is, if we can do so. As it is means, if fx is x by 1 plus x, we'll take gx as x by 1 plus x, because coming numerator and denominator degrees are coming as same only. Okay, if it is coming and same, then we can try same thing, means x by 1 plus x at gx. This is called successive approximation. You have to approximate the net integration x to x plus 1. The result should come as gx fx1, that is x by 1 plus x. We'll try with x by 1 plus x, that will come as 1 minus 1 plus x integration. That will come as x minus natural log of 1 plus x. Limit is x to x plus 1. If I put the limit, it will become 1 plus x minus natural log of 1 plus x. If I settle down separately, x minus natural log of 1 plus x. X minus the natural log of 1 plus x. If I settle down separately, if I take x plus 1, then it will be x plus 1 minus x. It will become 1 only, knowingly, unknowingly. 1 minus and natural log of x plus 1. First, if I put x plus 1, it will become x plus 2 minus x plus 1. So it will become 1 minus, and now in bracket, ln x plus 2 minus ln x plus 1, x plus 2 by x plus 1, ln 1 plus 1 by x plus 1. Makes sense? Okay, altogether it will become 1 minus natural log of, in bracket, 1 plus 1 by 1 plus x. Okay, now let's expand the natural log. If I expand through the Taylor or Maclaurin, Sir Taylor or Sir Maclaurin series, then it will come as the expansion of natural log 1 plus x is x plus, x minus 1 by 2 into 1 by x square plus 1 by 3 into 1 by x to the power 3 minus 1 by 4 into 1 by x to the power 4, like so. How it is computed? It is very easy. Means the Maclaurin series is, if there is a fx, then first term will be f0. So log of 1 plus x, x0 means log of 1, that is 0, gone away. What about the first term? dfxy by dx at x equal to 0 into x. dfxy by dx is 1 by 1 plus x. At x equal to 0, it is 1 only. So it will become x only. So x plus d2fx by dx square. First differentiation of log 1 plus x is 1 by x. Next differentiation is minus 1 by 1 plus x square. If I put x equal to 0, it will come as minus. Minus, it will come as minus. Minus x square by factorial of 2. More or less minus x square by 2. Similarly, if someone proceed, if I take triple differentiation, then it will come as plus. It will come as plus, but 2 will be outside. Minus 1 by 1 plus x whole square. Again, if I differentiate, it will result in 2 by, it will result in 2 by 1 plus x to the power 3. Okay, at x equal to 0, it will become 2. It will become just 2. So 2 into x to the power 3 by factorial of 3, as per the Maclaurin series, it will become x to the power 3 by 3. More or less, the Maclaurin series of natural log 1 plus x is x minus 1 by 2 into 1 by x square plus 1 by 3 into, I'm sorry. The Maclaurin series of 1 plus x is x minus 1 by 2 minus 1 by 2 into x plus 1 by 1 by 3 into x to the power 3 minus 1 by 4 into x to the power 4. Now we have natural log of 1 plus 1 by 1 plus x. So it will go as 1 by 1 plus x minus 1 by 2 into 1 by 1 plus x plus plus 3 plus 1 by 3 into 1 by x. Hope, we will start again. Natural log 1 plus 1 by 1 plus x will be 1 by 1 plus x minus 1 by 2 into 1 by 1 plus x whole square plus 3 plus 1 by 3 into 1 by 1 plus x to the power 3, like so. Makes sense? Now we will place here what we had received earlier. The earlier what we received is x minus 1 minus natural log of 1 plus 1 by 1 plus x. If I expand like this, then it will become 1 minus 1 by 1 plus x plus 1 by 2 into 1 by 1 plus x whole square minus 1 by 3 into 1 by 1 plus x to the power 3. It will go like this. If people are watching it, this side we have fx as 1 minus 1 by 1 plus x. Whereas this side we are getting as 1 minus 1 plus x as first term. And then 1 minus 1 plus x, then plus 1 by 2 into 1 plus x whole square minus 1 by 3 into 1 by 1 plus x to the power 3, like so. So first two term is same. These extra term is burden on us. If it is burden on us, then we will, let's take only up to up to two part only. Two part means 1 by 2 only. 1 by 3 I am not taking now. If that is the scenario, then I have, now we have on the right hand side we have 1 minus 1 by 1 plus x plus 1 by 2 into 1 by 1 plus x whole square. This term is extra, where a left term is exactly matching the fx. Means this I have to subtract and try again. Okay, we tried 1 minus 1 plus x. Now I have to subtract, because here it is addition. So I have to subtract with 1 by 2 into 1 by 1 plus x whole square. Net gx, new gx is 1 minus 1 by 1 plus x minus 1 by 2 and in 1 by 2 into 1 by 1 plus x whole square. This I have to integrate now and integrate now and set x to x plus 1 and try again. If we try it, then 1 minus 1, 1 by 1 plus x would become what it became earlier. 1 minus a natural log or something like that. 1 minus 1 by 1 plus x plus 1 by 2 into 1 by 1 plus x whole square. Let's settle down the see what is coming as minus 1 by 2 1 plus x whole square. If I integrate this, then it will become plus 1 by 2 1 by 1 plus x whole square. If I integrate it, it will become kind of 1 by 1 plus x minus plus 1 by 2 into 1 by 1 plus x. This is what it will become. Now limit is x to x plus 1. 1 by 2 I can keep outside. It will become 1 by x plus 2 minus 1 by x minus x plus 1. It will become minus 1 by x plus 1 into x plus 2. Make sense? Okay. Now if we see the older one we had extra term was 1 by 2. 1 by 2 into 1 by 1 plus x whole square. Okay, and here we have here we have 1 by 2. I'm not taking care about the negative and positive. Okay, pardon me. So here we had extra term as 1 by 2 1 plus x whole square. Here extra term we are getting as 1 by 2 into 1 by x plus 1 x plus 2. More or less they are same one. 1 by 2 into 1 by 1 plus x whole square, and here 1 by 2 into 1 by 1 plus x into 2 plus x. Means it is near to x plus 1 into x plus 1 only. Means it is working. Means we can take as it is and go ahead. So gx we have now represented as gx equal to 1 minus 1 by 1 plus x minus 1 by 2 into 1 by 1 plus x whole square gx. Now let's proceed with now what is the actual integration? Actual representation is sigma x equal to 1 to n fx should be equal to limit f1 to n plus 1, 1 to n plus 1, gx dx. This both should be same. Dx we have got as 1 minus 1 by 1 plus x minus 1 by 2 into 1 by 1 plus x whole square. We'll proceed now. Limit is from 1 to n plus 1. Okay, we'll try now. N section we have divided gx. One integration is x 1 to n plus 1 means n plus 1 minus 1 that will come as n only. So n minus natural log of 1 plus x minus and in bracket natural log of 1 plus x that will go from 1 to n plus 1. So natural log of n plus 2 minus natural log of 2, 1 plus 1, 2. So whole become n minus natural log of n plus 2 plus logarithmic of 2 minus minus plus logarithmic of 2. So we have got it. N minus natural log of n plus 2. If you remember through the repeated addition, we had received natural log of n plus 1. Here it is n plus 2. That is the difference. So n minus this solution is not available in any of the book. This is $1 trillion solution. Okay, I can sell it also. Means no one knows it. N minus natural log n plus 2 plus natural log of 2. Okay, now let's settle down the last one. Minus 1 by 2 into 1 by 1 plus x whole square. Integration will come as 1 by 2 into 1 by x. 1 by 1 plus x. Integration of minus 1 by 1 plus x whole square will be minus minus plus 1 by 1 plus x. It will become plus 1 by 2, 1 by 1 plus x. Limit is 1 to n plus 1. If I set n plus 1, it will become 1 by 2 into 1 by n plus 2 minus if I set 1, it will become minus 1 by 4. 2 into 2, 4. Okay, what is your net result? So net result is n minus natural log of n plus 2 plus logarithmic of 2 plus 1 by 2 into 1 by n plus 2. Okay, minus 1 by 4. Someone can proceed third term, fourth term of the Maclaurin series. There is no problem in that. It will give more clarity. Can someone try n equal to 1? If n equal to 1, there is no constant. This is what it is. N equal to 1. If n equal to 1, then n is 1. 1 minus natural log of n plus 2. Natural log of n plus 2 is natural log of 3. Natural log of 3 is 1.1. 1 minus 1.1 is minus 0.1 plus natural log of 2, 0.7. That will come as 0.6. It will come as 0.6. 0.6 plus 1 by 2 into 1 by n plus 2, 1 by 3 plus 1 by 6 minus 1 by 4. Makes sense? 1 by 6 minus 1 by 4, how much it will be? If I take 12 as denominator, then it will come as 3 minus 1. 3 over 2 minus 3. It will come as minus 1 by 12. I think so. Minus 1 by 12 means 0.6 minus 1 by 12. Minus 1 by 12 is more or less 0.1 only. Means it will come as around 0.5. Someone will say it is not 0.5. It will come around 0.51. Then the other portion, and this portion is also not perfect. If remember, we had done approximation because the expected was 1 by 2 into 1 by 1 plus x whole square. and we had got 1 by 2 into 1 by x plus 1 into x plus 2. There I have to do x plus 1 and then do the final settlement to get another one. But whatever it is amazing, mind blowing. If someone sees the bookish result, it will not be that perfect. The actual result of n equal to 1 is 1 by 2. Here we are getting 0.51. That is 1 by 2 only. Someone can, okay, understood, understood. Can you try n equal to 3? Okay, we'll try n equal to 3. N equal to 3 means log n. I'm sorry, n is 3 minus log of n plus 2. Then now log of 5. I believe for 5 it is around 1.6. This is what I remember. The natural log of 5 is 1.6. So it will become 3 minus 1.6. That will come at 2.4. 2.4 plus 0.7. That will come as 3.1. It will come as 3.1. 3.1. Rest we will see. What is the actual result? 1 by 2 plus 2 by 3, 1.17. 1.17. Okay. 1.17 plus 3 by 4. That will come as 1.92. So it should come as 1.92. Okay. 1.92. What we are getting? N equal to 3. So 3 minus log of n plus 2, log of 5. So log of 5 is 1.6 around. So 1.6, 3 minus 1.4. 1.4 plus 0.7. That will come as 2.1. And actual result should be 1.92. 1.92 and 2.1 we are getting. Now next is 1 by 2 into 1 by n plus 2. N is 3. 3 into plus 2, 5. 5 into 2, 1. 10. 1 by 10. 1 by 10 minus 1 by 4. 1 by 10 is 0.1. So we have to add 0.1 again. Then it will become 2.2. 2.2 minus 0.25. 1.4 is 0.25 only. 2.2 minus 2.5 will come as 1.95. Expectation is 1.92. We are getting 1.95. It is exactly same. Other we had not taken care. It will come exactly same. Okay, let's take n equal to 6. N equal to 6. Then what this side? 1 by 2 plus 2 by 3 plus 3 by 4 is 1.92. What is 4 by 5? 4 by 5. 4 by 5 is 0.8. 0.8. Then 1.92 plus zero point 0.8 will come as 2.72. Will come as 2.72. 2.72. Now we have fifth term. That is 5 by 6. 5 by 6 will come as 0.83. 0.83. So 0.83, 2.72 plus 0.83 will come as 3.55 around. 3.55. 3.55 plus 6 by 7. 6 by 7 will come around 0.9, I think. So we have 3.55 plus 0.9. It will come as 4.45. 4.45, I think. 4.45. If I'm forgot it, but this is how it is. 4.45. First was 1.7, 1.92. Then it got added with 4.5 is 0.8. 2.72. 2.72. Then it got added with the 5 by 6. 0.8 something like that. 2.72. 3.5. And then with this 4.45. 4.45 is the result when n equal to 6. Now let's try. N is 6 minus natural log of 6 plus 2. That is natural log of 8. Natural log of 8 is around 2.1. I think so. 2.1. Okay. So 6 minus 2.1. 6 minus 2.1 will come how much? It will come as near to 4, 3.9. 3.9, I think so. 3.9 plus zero point 0.7, then it will come as 4.6. 4.6. 4.6, and then we have 1 by 2 into 1 by n plus 2. N is 6, 6 to 8, 8 into 16. 1 by 16. 1 by 16 will come as around 0.06. 0.06. What we have now in our hand? In our hand, we have 6 minus 2.1 that came as 3.9 plus zero point 0.7 came as 4.6. 4.6 4.6 minus zero point 0.07 or something like that. Then it will come as 4.53. 4.53. Up. I'm sorry. We'll try again. N minus means 3.9. 3.9 plus zero point 0.7 is 4.6. 4.6 minus, it will come as 4.5553. 4.53, I think so. No, that is plus, not minus. 4.6 plus 4.7 more or less. 4.7 minus 1 by 4, 0.25, 4.45. Yeah, 4.45. This is, we will try next session, the left one. We have not taken, this is, we have taken integration of x to x plus 1. We will try x minus 1 to x. Okay, and we will see, we are getting similar result. This is something that is not available in the book. This will bring exact solution, exact solution. By after decimal, it will go up to n limit of exact solution. This approach is not available in any of the book. Anyone can try. It is absolutely not available. It is exactly same we are getting. This is considered as a tedious summation series. 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5. No one has found out the exact result. This is the exact result. We'll proceed more on it. Please don't mind supporting us or mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is India country code. 9483160610 is the telephone number.